Okay, we want to look at composite functions. Now, we understand that this is addressed people who know the definition of composite functions, but here's an example of something we can do with composite functions. If we have the graph of two composite functions, g of x and f of x, and I've used g sub e of x to indicate that the g of x function is our basic reciprocal function extended. The extended basic reciprocal function, which I define to be the reciprocal function that you get when you use 7 basic x values, -2, -1, -1/2, 0, 1/2, 1, and 2. And you omit any of those values for which the function is undefined or for which you don't know how to calculate the function other than to punch it into a calculator. You have to be able to do the arithmetic, in other words. Okay, so that the g sub e of x function, well, here it is. We don't use 0, and we don't try to extend the graph from here to here because division by 0 is undefined. It cannot be defined in any sensible way. It's undefined. Okay, reciprocal is 0, undefined. So this on this whole vertical line, which is where x equals 0, you don't have a value. And if you try to extend the graph across this line, you would be declaring that to be the value, whatever the coordinate on your y-axis is when you cross over the line, you would be declaring that to be the value of 1 over 0. That doesn't work. Okay, so anyhow, here's the g of x function. It's not defined. Okay, the extended function is defined only from this point to this point and from this point to this point. We don't have its value at any other points between here and here. Okay, and then the f sub e of x is your basic extended 2 to the x function, and that's not what I drew, is it? I went and drew the basic squaring function. So I'm going to have to stop here for a minute and fix that. Okay, I've made a correction. And now here are the values of the 2 to the x function at the values -2, -1, -1/2 of 0, 1, 1/2, 1, and 2, at which we can evaluate the function using basic arithmetic. We don't include the -1/2 or the 1/2. That's because you don't know how to calculate that. I don't know how to calculate it exactly because it can't be calculated exactly. It's an irrational number. The decimal expansion just keeps going on forever and never repeats. You can never say exactly what the value of that function is, but it does have an exact value. And I'm not going to go into details about how we establish that. Unlike g of x, where we don't connect the graph across a point where the function is undefined, 2 to the x is perfectly well defined at -1/2 and 1/2. But we don't know how to write the function other than to use symbols. E for the symbol, for 2 to the 1/2 or 2 to the -1/2. You can't calculate that exactly. You don't know how to calculate it even approximately. So we don't use it. But it doesn't mean the function's undefined there. So we can extend the graph right across -1/2 and 1/2. And now I'm going to do that. These are the functions. These are the points of the basic exponential function, which we might call f sub b of x. We extend that by starting at this point and moving through all the points with a nice smooth curve. Another thing we might do is we might put a big old fat dot here and here because this function is defined at -2 and it is defined at -1, and a big old dot here and a big old dot here. And same thing over here. function is perfectly well defined at both of these endpoints. Okay. Well, now the domain of this function is from -2 to 1/2. The x values from -2 to 1/2. And here, x values from 1/2 to 2. So those two intervals, the interval -2, -1/2, and the interval 1/2, 2, are both part of this domain. So we say the domain is this union with this. Union being the set operation that I assume everybody's familiar with. It just means you're in the set if you're in this or in this. Excuse me. The range is a set of all y values. Now the y values, the y value here is -2, -1/2. Y value here is -2. So everything from -2 to -1/2 is in the range. So there we have it. And also everything from 1/2 to 2. For the f of x function, the domain is everything from -2 to 2, all numbers from -2 to 2. And I also wrote down something that was right for the function that I drew, but wrong for the function that I said I was going to do. And that is the range, and the range doesn't include 0 either. Okay, the range of this function, if you project every point over to the y-axis, the lowest value, the smallest y value you're going to get is 1/4, which is what you get when x is -2. So the range is 1/4, 4. Okay, now we can write the expression for f of g e of x, or g of f sub e of x. The expression for f of g sub e of x, well, f of x, f e of x equals 2 to the x. So if we replace x with g e of x, which is what this means here, this is just like, this expression is just like this expression, except that x has been replaced by g sub e of x. That means we have to replace this x by g sub e of x, and we get to the g sub e of x. And of course, we have a formula for g sub e of x. That's going to be 2 raised to the 1 over x. Now that's something you can calculate if you have the right values of x. It's something you can put into a calculator. But calculating it, putting it into a calculator doesn't show you what this really means as much as looking at the graph and making estimates. Okay, so anyhow, f of g sub e of x is going to then be this, and we'll come back and refer to that, but we're not actually going to use that much in what we're going to do next. And g of f e of x is, well, g e of x is 1 over x. So if instead of x, we put an f e of x in here, then we're going to have to put the f e of x here too. So we're going to have 1 over your f e of x. That almost looks like a C. There we go. Okay, 1 over f sub e of x. And of course, f sub e of x is 2 to the x, so that's 1 over 2 to the x. Of course, this could also be written as 2 to the negative x if you wanted. Okay, this is fine. This is fine. Okay, those are the formulas. Now let's get away from the formulas and look what the graphs are telling us. F of g sub e of 3/2. What is f of g sub e of 3/2? Well, you got to evaluate f at whatever value g has when x is 3/2. So we know that ge of 3/2 can be estimated from this graph. It can easily be calculated too. It's 2/3, but we're going to estimate it. So here is 3/2, and let me use a different color. Here's 3/2. Come up here, and then we project straight across to the y-axis. So here's x equals 3/2. And here is GE of X, at least if we've made a completely accurate graph and done good projection, going vertically upward and then horizontally across, parallel to the y-axis, parallel to the x-axis. And we see that GE of X is between 0.5 and 1. Now, it's not all that close to 0.5, so I'm thinking it's between 0.6 and 0.7. 0.75, of course, would be halfway here. So I'm going to say, according to the graph, this is 0.7. Then f of g sub e of 3/2 would be 0.7. And I'm seeing something here I want to modify a little bit before I go on. Let's be more specific about what this point is. This point is GE of 3/2, isn't it? Not just GE of X. Now what I wrote was okay, but this is a little more specific. GE of, so I said X was 3/2. It was okay to write that as GE of X technically, but it would have been a better idea to write that as GE of 3/2. Okay, so that's f of 0.7. And this 0.7 was obtained by an estimate. So I'm going to put a little purple under it, using purple to indicate estimates, at least to represent estimates. Okay, now what's f of 0.7? Of course, you could say, oh, well, it's 2 to the 0.7 and 2 to the 0.7 is, well, what is 2 to the 0.7? Okay, you don't know. Okay, and if I'm going to do 2 to the 0.7, I'm not going to calculate the Taylor expansion, 3 or 4 terms. I'm going to ballpark it in my head. I'm going to say, well, okay, so here is 0.7. And I project up to the curve and across. And here is f of g of 3/2, which approximately equals fe of 0.7. Now, let's see, this is 1 and this is 2. The way I projected this, it's a little below the halfway point. I could easily estimate that to be 1.4 or 1.5. I'm going to say, according to this graph, it's a little less than 1.5. I'm not sure it's far enough less, but it kind of looks up to me. Maybe it's because of the angle I'm looking at. Okay, so I'm saying that's about 1.4. Okay. Well, we can do more estimates. Okay. What about G of GE of 3/4? Well, GE of 3/4 is estimated. Here's 1, 2, here's 1/2. So 3/4 is halfway between here and here. So I can come on up to the graph and then come on over to the y-axis. And I've got this point. Now the x equals 3/2 is here. Leave myself room to draw much of an arrow, but I'm going to draw it anyway. Here's your x equals 3/2. Here's x equals 3/4. So I'll say x equals 3/4 here. So here is GE of 3/4. And that approximately appears to be, well, let's see. Now, if this is 1 and this is 2, halfway between 1 and 2 is here. And this is a little closer to 1 than it is to 1.5. So I'm going to say GE of 3/4 is approximately 1.2. It might be 1.3. I don't think it's 1.1. You have to make your own decision about what you think. But do it carefully, do it accurately. Okay, well then GE of 3/4 would be GE of 1.2. And now we have to go to the G graph, and we have to go over here to 1.2 because we've got to do GE of 1.2. Okay, well, I'm going to change my color coding here a little bit. 1.2 is about here. And GE of 1.2 is about here. Now let's see, my GE of 3/4 is about here. Okay, my GE of 1.2 is about here. If this is a half and this is 1, this is 0.5, and this is 1, that looks like it's somewhere between 0.7 and 0.8. It's a little more than halfway. So I'm going to say it's probably closer to 0.8 than it is 0.7. And then I'm going to say that GE of 1.2 approximately equals 0.8. And that'll be this value. And this value here is, hope this doesn't get in the way of something else I want to write. I think I planned this better. Okay, X equals 1.2, and that's this point. Okay, so we then say that GE of 1.2 is approximately 0.8. Now these estimates are not accurate, not totally accurate. They shouldn't be expected to be totally accurate. They're estimates, but they give you a more tangible understanding of what these graphs are telling you, and they give you a more tangible understanding of the function than, let's say, moving points around with your mouse on a computer screen. We're making eyeball estimates on the computer screen, especially if you're not writing these things out and getting the tactile connection. Everybody's brain's wired differently. Some people do better with one thing than the other, but this is missing from the My Open Math materials. And you have to kind of make yourself do these things. Okay, make yourself draw these, make yourself label them. Doesn't take that long, especially if you're not doing it for my consumption or somebody else's. You can be pretty sloppy with it and still get the idea. You don't have to be meticulous. Okay. Now for assignments I give you, for written assignments, you want to be a little more meticulous and you want to represent your work with a little pride and accuracy. Okay, well, so here we have it. Okay, well, let's try to do GE of FE of 3/4. Okay, now that means we get to come over here. And, naturally I picked 3/4, which is really close to something I was going to use, but that's okay. So I'm going to use the yellow to distinguish, but here's 3/4. Which is, of course, 0.75. It's here in the graph, halfway between 1/2 and 1. And then if we project up to the graph, I'm moving out a little too far, so I'm not going to get a very good value here. I want you to be able to see the difference between these marks. Okay. And I estimate here, well, here we've got 1, and here we've got 2. And this was 1.4, so we got 1.5. I'm going to say it's 1.6, maybe even 1.7. So FE I'm going to say approximately 1.7. If your estimates are just within a tenth, usually, they're decent estimates. Okay, So that would be GE of 0.75. Now, luckily I've got a 7 there, so I'll just say fudging a little bit. GE of 1.7. And GE of 1.7 is what? Well, things are a little crowded over here again, but come over here where X is 1.7. We project up here. We project over. And now I can squeeze in another estimate. GE of 1.7 is going to be here. I'm saying that's approximately 0.6. So over here, I say that this is approximately 0.6. Now you can go to your calculator and see how I did. I really don't know. I haven't calculated these. Okay, so you can make your own judgment. And when you do these yourself, if you actually have one of the basic functions or a function, any function that you have a graph of or can make the graph of, you can do your estimates and then you can check them in your calculator. Now there's bound to be a little bit of error. There's a little bit of error when you estimate GE, and then there's a little bit of error when you estimate FE on this first graph. And those errors compound each other. If you're off by 10% here, and then using that value, you're off by 10% here, you got to be off maybe a total of something close to 20%. Actually, 21%, but we won't worry about that. Okay. So you don't expect to be totally accurate, but you do your best to be accurate to within a tenth, even by the time you get to the end of the estimate, and see how you do. See if you develop that skill. It'll make you understand the functions much better. Okay, well, what if we do GE of FE of 1/2? Okay, well, FE of 1/2, and I'm not going to do a huge amount of labeling here. I'm just going to do a projection up here from 1/2. We know this is 1/2. And if we come up from here, we hit the graph and we come over here. And this is FE of 1/2. And if this is 2 and this is 3, that's going to be, I'm sorry, this is 1 and this is 2. It's going to be about 1.2. Then GE of 1.2 has already been estimated here. GE of 1.2 is about 0.8. Now, what if we want to do GE of FE of 3/2? Well, then we get to come all the way out here. Here's 3/2. And we project up here. And then we project over here. And we see FE of 3/2, 2, 3, about 2.6. Okay, so that would be GE of 2.6. Okay, so we can come over here and we find 2.6. Well, let's see, here's 2. Okay. And I probably should have gone ahead and, yeah, I did. There's 2. Here's 2. 2.6 is out here. Our curve doesn't go that far. Now, for the complete function 1 over x, our curve can go as far as we want it. But for the extended function, which is what we've specified here, 2.6 isn't in its domain. So we're going to say that this has no value. There's no result. .6 is not in the range of the GE function. So we have to be careful when we talk about these functions. We have to be careful about the range. Okay, so we can conclude from this that I've written this backwards from the way I want to. I'm going to write, this is true, but here, domain cannot include x values for which fe of x is not in the domain of GE of x. Now I've made a statement here. I don't have, I've not included an example of where this applies. But the domain of fe of GE of x, in this case, is the range of GE of x. Okay? Because every element in the range of GE of x, well, actually, every element in the range of GE of x is in the domain of f of x. Because the range of GE of x includes the interval -2, -1/2. That's from here to here. Clearly, every one of these x values is in the domain of this function. And this interval, 1/2 to 2, well, 1/2 to 2, every one of these x values is in the domain of f sub e of x. I'll say that since every number in the range, since the entire range of g of x is included in the domain -2, 2, of f of x. What about the range of FE of x, FE of g of x? Well, the range of FE of x includes only numbers that you can get by plugging in numbers in the domain of FE of x, of GE of x, sorry. Okay. And those numbers go from -2 to -1/2, and from 1/2 to 2. So what you have to do now is say that the range of FE of x, and I'm going to have to draw this here, and I'm going to have to draw it a little smaller. But here's your, without putting in a lot of details, here's your FE of x. And here is, let's say -2, -1, -1/2. And here's 2, 1, and 1/2. The only numbers you can get out of, I've miswritten this, hang on. Not the range of FE of x, which is what we said here. The composite FE of GE of x. The only numbers that can go into FE are numbers that come out of GE. And the only numbers that come out of GE are the numbers in the range. So that here's the range, here's part of the range, and here's the range. Okay, so this is range of G sub E, and there are closed dots at the ends of the range. And the only numbers that you can get out of F sub E are the numbers that occur when you plug these numbers into the function. Okay, so the range of FE of GE of x consists just of the numbers that you get, the y values that you get from these points. And from these points, so here, the range goes from here to here, and here to here. Just here, in this little segment down here. Now, if I did that over here, it'd be a little clearer. So here and here, you get the range of G of x, GE of x. So the function FE of GE of x is just this. And it doesn't consist of this segment here because none of the numbers you need to get these values can possibly come out of this function, not out of GE of x. Now, if you say G of x is 1 over x, and that's a complete basic reciprocal function, then you do get these numbers. Okay, well, that illustrates a few things about domains and ranges of composite functions and about the connection between the graphs of two functions and the values of the composite. Again, if you make estimates, then you can use these formulas to check your estimates. You might say, why bother doing this? Well, I think I explained that earlier. It connects you to the function so that you're not just punching buttons, and it helps you remember what all this means. If all you remember is the sequence of buttons you punch or the mouse operations, all of which are good, you don't understand the function nearly as well, and you don't remember things as well. You don't retain it, and you don't apply it then the next time you need it. So there we have it.